Hello everyone, welcome to the Smart Interviews YouTube channel. I'm 𝗟𝗲𝗃𝗃 and in this video we are going to discuss the third question from LeetCode's by weekly contest 412. If you did not watch our previous video where we discussed question number 1 for this, I would suggest you do that because both of these questions are related. Okay, so now let's dive into the problem. So the question is called as final array state after k multiplications 2. So as same as the previous version of this question, we are given a integer array nums and an integer key. Along with it we are given multiplier. So we have to perform a operation k times, and in each operation pick the minimum value. Let's say x is the minimum value, and update the value of x with x times multiplier. So that is the question. And here we have to apply modulo. After k operation, we have to apply modulo 10 power 9 plus 7 to each value of nums and return it because the values can become very large. So we have to finally return what will be the array after k operations. Okay. Now the question is quite similar, same as the first question given in the contest, but the difference here is the values are quite large. The constraints given to us are quite large. In the first video, what did we do is for each iteration of k we found out the minimum element and we updated the value. But here the k value is 10 power 9. Iterating for 10 power 9 times will give us a TLE, and finding the minimum element is going to take 10 power 4, 10 power 13. It's quite large. So yeah, this is going to be an obstacle for us, and so we cannot go with the brute force approach. So we'll try to solve this in optimal way. Okay, so before let's move on to the solution. Let's try to understand by taking a simple example. There are few things that we have to notice to solve this question, kind of a pattern. So what we'll do is we'll start with a example. Okay, so here I have a example for us. Yeah, here I have an example for us. This is the array which is in our hands. Okay, now we'll the value of k, let's say it is 100. Okay, value of k, let's say it is 100. So what we'll do is we'll try to manually simulate for 100 times and see before reaching those many times can we find any pattern. Okay, so first find the minimum element. So minimum element is 8, so it will become 16. Next, the array is going to remain as it is. Okay, so what we'll do is 8 becomes 16. Next, in next operation this 8 will become 16, right? So now this became 16. Next, minimum element is 10, first 10. This will become 20 because we are multiplying it by 2. Next, this one will become 20 because we are multiplying it by 2. Next, this 12 becomes 24. Okay, next 5 operations are done. Now we have more 95 left. Let's do that. Okay, next, what will be updated? We will be updating 16 and it becomes 32. Next, the 16 will be updated to 32. Next, 20 will be updated to 40. Next, this 20 will be updated to 40. After that, 24 will be updated to 48. Now before moving on to the next 5 iterations of k, so for that, after completing the first n iterations, n is 5, right? N is 5. After completing the first 5 iterations, we are actually generating the same pattern again. If you see, first let's look at our order, how we affected our elements. First we touch the what indices did we touch? First we touched 0, next we touched index 1, next index 3, index 4 and index 2. Now here if you see, first we touched index 0, next index 1, after that index 3, index 4 and index 2. So if we repeat all these operations again and again, what are we going to do? We are going to do this thing same thing again and again, right? Again, you'll be touching the next minimum value, which is going to be index 0. After that, index 1. After that, index 3 is going to be the next minimum value. Next minimum value is 4, 2. So like this, we are going to repeat this operation again and again and again. So instead of doing that, can't we find the final answer directly? So how many times is this cycle repeating? That will be simply nothing but k by n times, right? K by 5. So k by 5 will be k is 100 by 5 will be 20. We are going to multiply each value 20 times if we are going to look at it in this way, right? If we are going to look at it in this way, we are going to multiply each value 20 times. So what I am saying is 8 into 20, 2 into 2 into 2 into 2 into, and so on 20 times. That means I can replace this entire thing. With what? Simply 8 into 2 power 20. 8 into 2 power 20, right? So what will be my final output? 8 into 2 power 20. 8 into 2 power 20, 12 into 2 power 20, 10 into 2 power 20, and 10 into 2 power 20. So this is going to be my final output. Instead of iterating for 100 times, since I know there is going to be a repetition of elements, I can just do this, right? So if I know repetition is going to be there, all I have to do is this part. Okay, not all examples directly give us this repetition, but let's discuss about it shortly. But I think we understood the point. Till now it is done. Now what if we have something like, instead of k equals to 100, what if we have k equals to 103? Okay, k equals to 103. So what will happen in this case? We are going to pick first 3 minimum elements, right? So 100, 20 times it is done. But for the first 3 elements, we are going to multiply. 100 elements are already done. For remaining 3 elements, we are going to multiply with 2. So the minimum elements that we know, right? Into 2 for this, and into 2 for this. So this is going to be the sequence of operation. Okay. So what we can do is, for the picking out the minimum elements, what we can simply do is we can simply use a heap. Data structure. Okay, that is done. Okay, so for every value at last, we are going to multiply with let's say called cycles. So 2 power or m power cycles. Okay, there are 2 power cycles, so m power cycles, and whatever the remainder values we have, we'll pick the minimum elements from the heap and multiply let's say x into m for each of the values. And how many times are we doing it? For remainder amount of times. Okay, so this is the logic. So let's try to understand why is this actually happening. So if we try to understand this, it is quite simple, right? So where we got to a point is, these numbers are so close to each other. These numbers, that is 8, 8, next let's call this as 12, next this is 10 and 10. Okay, these numbers are so close to each other. Once we multiply them with themselves, okay, the minimum number that we are taking will become the maximum number in the available array, right? Minimum number that we are taking, that is becoming the maximum element in the array. So what will be the minimum element? This will be the minimum element. It became maximum. Next, this was the minimum element. Now it became the maximum element. Next, whatever minimum is there, that is going to multiply and it is going to become the maximum element. So in every operation this is happening, and this is kind of forming a cycle that every minimum element that you are touching is becoming the maximum element. And how many times is it going to continue? It is going to continue until you also touch the maximum element in the array, which at one point will become the minimum element, and once you multiply it again, it becomes the maximum element, restarting your cycle. Okay, so that is what happening here. And if we get this cycle logic, we can simply solve our solution. Okay, now you got this point, right? If we can bring the elements so close to them each other that multiplying the minimum will make it the maximum, we can form cycles. Okay, so how do we get to that point is the question. Okay, so yeah, let's take the sample example. Okay, sample input given to us, but first just want to move this aside. Let's talk about the sample example given to us. It was 2, 2, 3, 5 and 6. Okay, now the value of m was 2 and k was 5, but we are going to, let's say, do it for 100 times. Okay, so minimum element, so 4 next minimum, 4 next minimum is 3, so we'll make it 6 next minimum, 10. Okay, now again repeat it. 4 becomes okay, 4 will become 8, this will become 8, now this will become 12, this will become, this will not change this, and this will become 12. Okay, now can I make this statement that if the maximum element that we had in our initial array, okay, maximum element that we had in our initial array becomes the minimum element, can I say that we brought all values close to each other? Okay, can we say that we kind of brought all values close to each other? Yes, right? Now if you see, if we perform these operations and at one point, if after all values are updated, why are we updating? Like, why does this bring all values to close to each other? As we just discussed, we are kind of increasing the values, right? So we started with 2, 2 increased to 4, 4 increased to 8. So it was 6 here, it became like 8 here, right? So we slowly increased and we kind of brought all values close to each other. This is just a way for you to understand. But anytime we do this, after we can recognize a pattern that the after multiplying for some time in range of k, after multiplying it for some time, we get to this state after all values are multiplied with each other. Sorry, after every element of the array is multiplied, because the largest element we are touching. Now the minimum element that we are going to pick is going to be greater than the largest element for the default array. Okay, so when that situation comes, we enter a state where the elements that we have form a cycle. Now if you look at this array that we have in our hand, it is quite similar to the array we started in our example. Here we took 10, but here we can take 12. Right, it is quite similar to the array we have in our hand. This is the observation that you can make if you go through multiple examples, that once every element in the array is multiplied by once, there starts a cycle where elements multiply each other, multiplied with m, become the largest. Okay, the element which is multiplied with m becomes the smallest element we are talking about, becomes the largest element. So the next element will be the again largest, the third smallest will be the largest, and so on. We get to the largest element in the array, which will be the smallest. Once you multiply, it will be the largest element, and the cycle continues. So the idea here is, when you multiply the array again and again, pick the minimum element and multiply. At one point, the minimum element you pick in the array will be greater than the maximum element in the default array. At that point, what we can see is, there is a cycle forming after that operation. Okay, so this is going to be our logic. What we are going to do is, we are going to perform multiplication operation until the minimum element in the array, that is, we are going to use a heap to achieve that. The minimum element in the array is greater than the maximum element in the array. Until that point, we'll keep our operations. Okay, after that, what we find out is, these things that we have now are going to form a loop, so we can just count how many cycles we are going to get, and for each element we can multiply those cycles, and also for the remaining parts we'll just calculate the remainder with the given value of k and multiply for the minimum elements in the heap. This is going to be our logic, and we'll convert this into code and check how well it goes. Okay, let's continue with the code for this part. Okay, so let's continue with the code for this question. So first of all, as we discussed, we are going to follow all those steps. First, multiply, take the minimum value, multiply, update, that is, perform the operation, put it in heap until the minimum value we have in the heap is greater than the default maximum of the array. So first of all, we'll declare few variables. Let n be the length of the nums array, and we'll create mod. Mod is 10 power 9 plus 7, so 1e9 plus 7. Okay, then we also need heap, right? So I'll declare a list as my min heap. Okay, now in this I'll populate this min heap. So what will I do is, for I in range of n, I'm adding a tuple to this. So I need the index also. So nums of I comma I should know which index I'm updating, right? So the value and the index, nums of I comma I, and we'll just heapify the min heap. Okay, so this will create our min heap with smallest value at 0th index. Okay, next step, what else do we need is the max value, right? So max value of the array is maximum of nums. Okay, so yeah, next thing, while k is greater than 0, or while k will work, okay, k minus equals to 1. Now for each iteration, what as discussed, we'll pop the value. Okay, heap pop from the min heap, and so let's call those values x comma I. Okay, x comma I are the values. Yeah, so simply nums of I, so nums of I will be equals to x into multiplier, x into multiplier. Now we'll push this value back into the heap. Heap push into min heap, push the value of nums of I comma I. Okay, and yeah, k minus 1, because we have done one operation. Now what we'll do is, we'll check if the value we popped is actually greater than the max value in our array. Okay, if x is greater than max value, so this is the start of the loop, so we can just break. Okay, we can just break things. Now, as discussed, what we'll do is, since this is starting a cycle, we'll find how many times the cycle is occurring. So let's store the value of remaining first. Remaining is equals to k by n. Okay, remaining is k by n, and the value of k itself is, sorry, remaining is k percentile n, and value of k will be k by n. Okay, the value of k is k by n. Now first we will update the values in the heap. Okay, for I in range remaining. Okay, x comma I equals to heap pop from the heap, heap min heap, pop from the min heap, and nums of I equals to x into multiplier percentile mod. Okay, there is a reason why we did not apply mod in line number 11. Okay, once we apply modulo, the value will be less than 10 power 9 plus 7. Let's say we have some value which is 10 power 5 multiplied with 10 power 6 as our multiplier. So the value is actually 10 power 11. Okay, but if we apply modulo, it will be around 10 power 10 square, that is around 100, right? So we don't want, not 10 square, yeah, around that value. So we don't want that to happen, because that will be, it was supposed to be, let's say, maximum value, but it can become the minimum value. So don't apply modulo over there, you can apply modulo over here. Okay, nums of I applied modulo for each of the remaining values, will pop them, update them. There is no need of adding them to heap again. Okay, so that is done. Now let's say m power is the multiplier power that we need. So what we can do is we can simply calculate it. Power of m comma, that is multiplier comma updated with number of cycles, right, which is k, and we'll also pass modulo power. Okay, so this will give us m power k mod percentile mod. Okay, so now for each of the nums element we have to multiply it. So for I in range of n, nums of I will be equals to nums of I into m power nums of I into m power percentile mod. So this should do the trick. At last we'll return the nums. So let's just run it and check, see if we are having any issues, then we'll fix them. Okay, our code is working perfectly fine. So let's just submit it, the solution, and check. Okay, yeah, okay, yeah, we have to handle this test case. Yeah, let's handle it. If multiplier is 1, the minimum value remains the minimum value, so updating it for 10 power 9 times is kind of waste of time. So let's just add the case. Multiplier equals to 1, we'll return nums. Okay, just multiplier equals to 1, we'll return nums. Let's run it and check. I think, yeah, this will run fine without any errors. So we'll submit and check. Okay, let's see our submissions. Yeah, our solution is accepted. Okay, our solution is successfully accepted. So this is the end of this logic, this code for us. that is it for this question. If you want to understand more such topics and want to master data structures and algorithms, join our 3-month long DSA course. You'll find the link in the description. Thank you so much for watching this video. We hope you liked it. To enjoy more such content, please like and subscribe to our channel. Please let us know in the comment section what kind of videos you would like us to create. Thank you once again. See you in the next one.